Welcome back, 8th graders. We are on week 6. This is our first lesson for the week. In the textbook, we are on page 353, and that is topic 7, lesson 2. Let's go ahead and get started. All right, let's start off as per usual with a quiz. What was your homework from last week, week 5? Was it A, there was no homework, B, week 5 quiz, C, dinosaur essay, or D, research project? 5, 4, 3, 2, 1. Let me eliminate some answers. Research project, no, I've never mentioned that. So if I don't mention something and it's in the multiple choice answers, that's the first answer that you should get rid of. And unfortunately, there was no homework, was not an option. So correct answer is week 5 quiz. Remember, you had all week to work on that, and hopefully you had some extra time to make up some work. If you're confused about what work is due, I posted it on updates on Schoology. If you have any questions, email me, message me, whatever you need to do. Make sure you're trying as best you can to stay on top of your work. I know sometimes it's a little overwhelming, but keep trying. I'm going to give you some cold, hard facts about air. Please remember air is a gas, as you can see in the right-hand GIF on the screen. The particles are not really together. They're super random. They're bouncing all over the place. This is what atoms of a gas look like, and air is a gas. So last week I taught you that warm air was less dense than cold air, which is more dense. And some new things I'm going to teach you about air this week is that air does not stay in one place. It flows. Almost think of it like flowing like a river from place to place. It doesn't stay in one place. Air also does not have a specific shape. It can take the shape of any container. And so I think a good example to think of this is like a balloon. Balloons come in all shapes and sizes. Your air that you put into the balloon doesn't change, but it's just going to take the shape of that specific balloon, whether it's a long balloon, a fat balloon, a wide balloon, a small balloon. So it's kind of flexible in that sense. All right, so why all this talk about air? And it's not just because I'm full of hot air. It's because today we're going to talk about wind flow. And if I can remind you from last week, wind is the horizontal or side-to-side movement of convection currents. And convection current is this pattern or cycle of warm air rising up because it's less dense, and air cooling down and sinking because it is more dense, and it makes that nice little pattern and flow. So we're going to talk about wind flow. But before I really get into the wind, I want to give you guys a life lesson that you are going to see a lot as you continue your career in science. And that life lesson is most things in life go high to low. Okay? Like gravity. If you are on a hill and you start rolling, you're going high to low. Let me give you another example. When you start a run, you're pretty psyched to start, you're high energy, and at the end of the run, you're pretty tired, you're low energy, high to low. Another example, heat that we talked about maybe 2 weeks ago now. Heat flows from high temperature, hot, to low, cold. So let me give you this example of you holding a coffee mug. The heat from the coffee mug is going to flow into your cold hand. So high to low. Let's talk about scent. Scent travels from high concentration to low concentration, and this is known as diffusion that we talked about earlier. So let me give you an example. If we have one of our lovely ladies take a perfume out of her purse and give it, squish, squish on her wrist, and maybe we don't see it, you can bet in a couple minutes we're all going to smell it again because it's going from high concentration from the bottle to low concentration throughout the classroom. This is also how farts work. So, usually the one who smelt it dealt it. So the one who farts first can smell it, but then after a while, you know that, hey, somebody ripped one in this classroom. The same way, it's diffusion of scent. High to low. High to low, the way to go. So what a coincidence. The flow of air is going to go from high pressure to low pressure, high to low again. And how do I get differences in pressure? Well, it's going to happen when there is uneven heating. For example, the beach. Remember I told you that water is really, really, really good at holding on to heat, and so that results in a temperature difference between the land and the sea. So the next slide I'm going to show you exactly how there is a difference in air pressure when we have different heating surfaces. So here we go. I've got two surfaces. On the left, I have a hot surface, and on the right, I have a colder surface. And those little blue circles are going to represent air particles. So let's start with the hot surface first. Well, what happens is those air particles above the hot surface, they're going to start to warm up. And what happens when air warms up? It expands, and it becomes less dense. And because it's less dense, it will rise. All right, so when it rises, what actually happens to air pressure is that air pressure will decrease. Now, the exact opposite is going to happen with a colder surface. So maybe you can take, 30 seconds and take a guess at what will happen. It's going to be the complete opposite of what happens at a hot surface. So I've got a cold surface. These little blue air particles are getting chilly. So what happens is they're going to come closer together. And as they become closer together, they become more dense and they will start to sink. Okay. Now, if air pressure decreased when the particles expanded and rose, what do you think is going to happen when particles come together and sink? Well, it's going to be the opposite of a hot surface, so air pressure is going to increase, okay? And boom, I have got an air pressure difference, and my wind is going to flow high to low, so it's going to flow from cold to hot. So that's exactly how wind works. All right, so if you're feeling a little confused about pressure, I'm going to show you something that works for me. When I think about pressure, I think about a can of pop, and I think about a cold, right from the fridge can of pop, and versus a warm can of pop, like a can of pop you accidentally left in the car too long. So when I have like the perfect Coke, I like Coke better than Pepsi, that's just my preference, but it's nice and it's ice cold, and you pop it open and psh, it makes that like really nice sound, and you're like, yeah, this is gonna be awesome. My nose is gonna burn soon. I'm probably gonna burp because there's so much carbonation. And actually, a can that is cold is at really a good pressure, and I feel like that Coke tastes the best. Versus a warm pop, and you open it and maybe it's not as a dramatic of a fizz, and you see that there's like not a ton of bubbles. It's like, I don't know, it's like really sickly sweet. It doesn't really feel refreshing. Some people like warm pop, but those people are clearly wrong. And it's actually because it's at low pressure, and the carbon dioxide that makes up the bubbles doesn't really stay in low pressure. So how can we relate this to what we learned? Well, cold pop equals high pressure. Cold pop is better. High pressure is better. It makes the pop taste better. Cold wind, like pop, is also high pressure. Versus warm pop is low pressure, and that's why it doesn't have as many bubbles. Warm wind is also low pressure. So that's how I remember it. I like cold pop. I like my pop to be carbonated, have lots of bubbles. The bubbles don't happen unless there's a lot of pressure. Pop that you leave out overnight, very low pressure, doesn't taste that good. So guys, this is how I remember it. If it doesn't serve you, if you don't find meaning in it, you definitely don't have to remember it like this. It's just something that I thought might help. All right, let's wrap it up. I'm trying to get this under 10 minutes. We shall see. What causes pressure differences on land? Is it A, heating on surfaces, B, radiation, C, wind, or D, the movement from high to low? 5, 4, 3, 2, 1. Wind, I'm going to knock out right away because wind is the horizontal movement, so that's not going to be it. I'm also going to knock out radiation because that's how the sun's energy first gets to Earth. So the correct answer is uneven heating on surfaces. That's it. I'm a little over 10 minutes, but hopefully that's okay. I will talk to you guys soon.